Hi, welcome to another video and episode of my Arduino Mega2560 using pulse width modulation motors, electronics, etc. And last time I tried to find out why, despite setting the correct frequencies, I reading wrong frequencies at several measuring points. Sometimes I read 120, sometimes something close and something completely off. I ended with enabling all these analog writes and setting them all to output value 1. That resulted in a better situation, but not quite so. So in this episode I want to find out why that happens. Not that I really have the illusion that everything works immediately, but at least I'm going to try. Possibly adding resistors, because it seems to be that with more or less resistors you get a high frequency. But if that is the case, I don't know yet. What I did find out also is that some frequencies are actually off the scale, which I find quite odd, to be honest. But anyway, that is the focus of this episode. So let's also start at reviewing the code. And by the way, in my blog on my website you can find back how I get into this information, and this information should be completely correct. So I should not have to change anything into this code. Should. If that is a correct assumption, I'm not quite sure. For instance, 7, 9 and 5, is that really a problem? That may be even so, now that I look at it. I might this is actually acting up, because at the input of 12, which is, by the way, if I look correctly, the output of the chain activated switch, that is high and low. And with the pulse width modulation I actually added some more visual effect to it, in the sense that it keeps flickering and flickering and flickering, and then whenever the switch is being activated, a short brighter flash. So this actually works still. Anyway, that's it for reviewing the code. Let's get to the circuit and see what happens. Last time I added this circuit, and or circuit anyway, one LED and these two resistors. last time also this LED flashed or flickered in the same way as these do. So the question is, why now? Why not now? Also, when I push on this LED, it burns. Letting it loose, it doesn't, obviously, and the reason I can only guess, but I assume that the contact with the breadboard is a little bit too small, too short. So the main question is, why is this not responding as it should? Which is, by the way, a very good question. Oops. Let me check on the connection to a 0. And that actually should indeed be a 0. So I will let that be. That remains, then the question remains, why is this LED not doing what it should do? And also, why is it this not as bright as it should be on contact with this? So all connectors seem correct. Let's measure some. It's frequency bound, so one probe here and one probe here. It shows 120, which is exactly what I need. So this is correct, and since this is coming from this way, I can measure this as well, and this should be 120 as well. Yes, it is. And this is coming from, where does it come from anyway? The yellow part, which is here, which is connected, and I have seen that I've shown that in previous episodes as well. It is coming from contact 3. And scrolling through the code, that connected are 2, 3, 4, 5, 6, 7. So they should all be 120 Hertz. And this one is from here, this one is from 3, no, 8. Is that among them? No, it's not. So perhaps that should be a little different. Determining the cause, because what is this frequency again? That is, this is 120 now, kind of, and this is around 120. So now these are alright. and there's no transistor in between, so that's one thing. Up to this. So now these are all 120 or something like that. The question is, does this have anything like that? This is around 122. This isn't, but this clearly is. This is too 130, 120, about it. Makes me wonder, this is the output. So when I measure once again here, it goes through the roof. This is not even close, and this is too high. So I wonder if no, and since this is too high, the motors aren't working. What is the voltage? That is important as well. So let me change the scaling, the setting to 20 DC. Measuring again here. That is -0, and this is -5. So, but this is completely now I notice that this one is probably set wrong. One of these motors, one of the contacts should be in the plus. So this should be a better one. That is for one thing, and you have noticed that the motor isn't there, but I'll change it. I'll just change the motor. Turn up the speed. And the only thing that happens is that I turn up the speed of the chain. And this isn't doing a thing. While in previous videos it ran very nicely. So why is this? It is really not doing anything. What is the difference in voltage? It is nothing. This is 5 volts because this because the circuit is 5 volts. But they always run nicely. So what is wrong? Is the frequency due to this? I really can't say. And one more thing, when does this motor get back to action? Not at all. So with these things more or less correct, I need to check on the rest. Before I go on with this part of the circuit, I just noticed that I turned up the spot meter and the bright flashes upon hitting the switch is happening again. So apparently that is due to both the pulse width modulation and the higher voltage. So with that conclusion, I go back here and try to get things running again, if it lets me. Anyway, there's no light here, which is quite worrisome. So the question is why that is, and it is coming from, not from here, but from here. Looking here, it is from port 2. So the question is, which voltage is on port 2? Measuring here again, and let's say here, it's 120 Hertz, kind of. But the voltage, let's take the voltage. 20 voltage should be okay to measure, and I found 5 volts. Going here is a wire bridge, because that is something that would explain it. No, here is 5 volts. Going here is more or less 5 volts. Going here, at this point behind the capacitor, is much less, of course. So what if I once again short circuit, and there you go. I'll show you. This is running because I short circuited this capacitor. What happens then if I short circuit here? Nothing. So I short circuit it, and I will measure. And that is 2 volts, but I am interested in frequency. So once again I short circuit it. I measure, and that is 14 kilohertz. No, I should measure. once again, short circuit, and measure. This is rising up. One short circuit again. And then measuring here, it's 120. And then it rises. So what if I replace this capacitor with a jump wire? What happens then? Or with a resistor, for that matter. Let's try that. So I'm taking out this capacitor. And putting in this resistor. Okay, time to measure things. Oops. It's varying in frequency. And it is not coming really to 120. Once I measure 130 as lowest, and that is a pity. 130 as lowest, too bad. What if I replace this capacitor by a resistor? Let's just do that. So let's put everything to rest for a moment. Alright, no hitting things for now, or not running things anyway. This one out, this one out, and this one in. Alright, let's see what happens now when I turn up the voltage. Higher then. Why isn't this one working? Now it is. Because there's a connector out. but still it isn't working. Now it's working. So once again, let's measure. What do we have? This is too much. 340, 400 Hertz. That is way too much. And this one is also too much. Very close, but too much. So I'm getting close, but not close enough. And I wonder why that is. I'll have to find a solution for this, but I'm coming very close. So with the whole thing working more or less, apart from this one, let's see if that one works or not. It's not doing anything, which may be due to a bad contact. Let's try again. It's not doing anything, unfortunately. But thank you for watching for this episode. Some unexpected results, some nice results. Who knows what next episode brings. I hope some better results even. If you like these videos, please consider supporting it by allowing advertisement, etc. Visit my website for my other projects, and this is going to be continued.